Well, welcome, ladies and gentlemen, for another afternoon in discussing a search for truth that leads to social justice. This year, we were supposed to have this year annual conference as part of the tradition of the Association for Good Government. And this year's theme would have been on the Science of Political Economy by Henry George and perspectives on the pandemic. But because of the pandemic, as you can see, we are limited to meeting in cyberspace rather than in a 3-star facility outside Sydney. And this is the third and final installment of the series of talks in discussing perspectives on the pandemic. Yours truly gave the first one on political economy, integrating economic efficiency and social justice. Last week, we had Dr. Ian Benson, who talked on the rule of law, the civil liberties still apply in a pandemic. And this afternoon, we are honored to have Tibor Molnar. Tibor and I have been friends for years, I guess over a decade, isn't it, Tibor? Right, we've bumped into each other several times in many of the fora around Sydney, Open Forum, Philo Agora, Philorum even.
Yeah, lots of places.
Yes, and thank you for this time gracing the Association for Good Government. And Tibor studied chemical engineering at University of New South Wales, where I also studied, but in a different decade. But then forged a career later on in information technology and business. He actively pursues a wide range of interests from physics and neurosciences to artificial intelligence and philosophy. He is an honorary associate of the Department of Philosophy in the University of Sydney, and he teaches philosophy and science at the WEA and is currently writing a book. And here he is with us today to give his viewpoint on can science and politics mix. So without much further ado, welcome aboard, Tibor. Thank you.
Thank you, Joffre, and good afternoon, everyone. It's a nice, small, intimate group. So what I'd like to start with is actually, I'd like to ask you a question. Before I tell you my views on science and politics, what I'd like to ask you is, what is it that you expect me to say, or you would like me to say? Or maybe you can tell me what you think science should be doing in relation to the pandemic, in relation to the political situation at the moment, that you think it is currently not doing. Because I'm not sure, I'm certainly in my experience around the traps, it's not entirely clear exactly what people's expectations are and whether they are the kinds of expectations that science perhaps even should meet. So let me invite Joffre to be the MC, and let's go around the room and ask people to tell me what they think they want to know about the relationship between science and philosophy. And then I'll tell you what I was going to say anyway, so it doesn't make any difference. But I really would like to know exactly what the general population, in this case, the people in the room in the Association of Good Government, I'd like to know what you think about what the relationship is or should be between science and politics. So Joffre, please take over and manage the responses.
All right. Anyone want to give the first question or cite his first expectation for this afternoon? Okay, Anthony, you raise your hand first.
All right. In the context of the pandemic, it's a great study, the science around the pandemic and the politics around the pandemic. And I feel that the scientific voice is muted, it's not heard. I don't know whether that's the problem of the scientists. I have my hunch, it's the media. The media and the politicians are sprouting the narrative. And the science of the pandemic, in my view, has been drowned out. It's all drama and it's all an emergency. But we always hear about cases, but never deaths. So the science has been muted. And even the scientists themselves aren't speaking out. They don't want to break ranks. They dare not go against the narrative that's being pumped out. So it's probably a comment rather than a question. In my view, with the pandemic, the science and politics can't mix. The science is somewhere there in the background. It would have deaths per million, and compare that with influenza and other causes of death. But it's been drowned out. So it's a comment rather than a question, but I'd invite your comment again.
Okay, well,
Anthony. Then the next will be John Dale. John Dale will be, what's your take, or what do you expect?
Well, I think we have a bit of a hiatus in non-development as far as the mixing of politics and science. As I've said on a couple of occasions previously, and I don't want to bore people with repeats, but one of the facets is that we get the politicians that we deserve. And our society is so busy surviving in a state of relative affluence that it doesn't take the time out to check what is going on. What is now becoming urgently required is identified by a couple of, effectively by a couple of MPs in the Labor Party. Not that I am totally, both major parties have bad form in my opinion, but the Liberal Party is notorious with its prescription for small government. What a hoax that is. You need government to be as big as is necessary to effectively deal with science, present science, and effectively look at evidence-based development. Instead, we have politicians who have been allowed to get away with being unaccountable, and there being no federal definition of due process. I've been at pains to talk about this for some time. We still have the problem. If we define,
John, let me interrupt you for a second.
Sure.
I didn't ask for a political diatribe. I don't want you to tell me your political position. What I'm interested in is the relationship between science and politics. So I don't think you're answering the right question.
I think that
you're talking about all the problems that politics has, but that's not my question.
Well, inherent in us getting the politicians that we deserve.
That's not a scientific question either.
That leads directly to the fact that they can get away with not using science. There can be no mix. That's the whole point.
Good. Okay. So you've made your point. You say that politics and science can't mix. Very good. Okay. I accept that. I'm inclined to agree with you.
All right. Thank you. So who's next? Please stick to the issue.
Any other takers?
Somebody wants to speak. I'll just have to convey. Okay, Fred, you first.
Yeah, I think politicians don't take science well into account. So there's not enough science in politics, I think, especially since the Trump era. There was a lot of sort of anti-science rhetoric around. That's
Is it the Howard area? What about Howard?
Howard.
Compare. What about the old Whitlam area? They had devotion to the arts, to the science, to everything. But after them, it didn't happen much there.
Elmore? Yeah.
No, I don't want to interrupt. I don't want to make
Okay.
a big speech. I just mentioned that the relationship between government and science now is pretty minimal. And the guy like Whitlam was on, they really devoted themselves to all the things the big government should do instead of a small government, you know.
Okay. Thank you, but I think that we're going into politics now.
Yeah, certainly.
Joe?
It's a very difficult question. Just to be clear, we're not talking about science and politics in general. We're restricting ourselves to the issue of the pandemic. Otherwise, it's such a huge question. I couldn't plow into it. But if we're talking about the pandemic, then I think I see it as basically two areas. The politicians do, as we see what they're doing. But I think the more interesting question is what the scientists should be doing, because it's not clear what they are doing. And it seems to me, particularly if you want to have some gel, some mixture between what the politicians are doing, what the scientists are doing, there needs to be information to the general public. There should be websites and all sorts of publications by people who are experts explaining what the current knowledge is of the situation. And I haven't been checking all the websites. I'm not sure what the situation is, but I believe they could do a lot more. Unfortunately, science is like politics. A lot of people don't realise it, that people have different opinions. Notable scientists differ amongst themselves on very important issues. So if you're going to explain that to the public, you actually have to explain one scientist says one thing and another scientist has a differing point of view. But if you're prepared to do that and you put some effort into explaining, not in science terms, but in terms ordinary people can understand all the scientific issues, then the people can themselves make more headway with judging what the politicians are doing.
Okay, yes, I don't disagree with that.
Okay. I'll convey the opinion of Ray, who's listening but can't be heard because of technical difficulty. She says the problem with science is and politics at the political problem with the science is the absence of certitude. Normally, when people talk about science, there is an amount of certitude and predictability. Apparently, at this point, there doesn't seem to be any certitude over the horizon as to how to deal with it, when it will be over. And my take, Tibor, would be when politics and science start sharing common economic interests, then I, as an economist, become doubly wary of the situation. And so I end up really looking at the problem from all the directions and try to make the economic or the commercial issue, which is different from economics, an irrelevant material, because what we are after here is, like what Ray said, certitude. What we have is usually the effect of causes. Now, I'd like to know what the causes are that led to the effect we have so that we can arrive at a solution that is scientific. That's my take on it.
Okay, good. All right. Well, thank you, everyone. it's interesting.
Time more. Yvonne, is Yvonne there? Yvonne might want to say something.
Okay.
She has,
I'll just say science is about research and investigation. It's not about opinion. I want to state that. And science should be given us a voice. That's all I'll say.
thank you, Yvonne. All right, sorry, back to you, Tibor.
Okay, no, thanks, Yvonne. That's a good point. I agree with you. Science is not about opinion. And in fact, they shouldn't be expressing opinions. That's not the role of science. Okay, well, generally, the opinion in the room seems to be that the problem is more on the politician's side than it is on the scientist's side. Most people were complaining that the politicians are not listening to the scientists. There's a minimum connection. I've heard that science, that even the society doesn't follow what's going on. They don't listen to what the scientists are doing. Maybe the scientists are not being heard. But it seems to be the problem is a political one more than it is a scientific one. And I will address that in my talk in a little while. I will say one thing at this point, and that is in response to Anthony. It is true that the scientists are not being heard. I went to a lecture at Newington College by Norman Swan, who is now Dr. Norman Swan, who's now a household name. Everybody knows him as Dr. Epidemic or Dr. Pandemic or something. He's on top of all of it. He knows the science, he knows the medicine, he knows a bit of the politics, and he is not told by the government who is on the government's scientific advisory panel. That's the government is keeping confidential. The government is not announcing and not allowing the scientists on that advisory panel to release to the public what the advice actually is. So what's happening is the government is stifling the scientific advisory panel, which is the medical advisory panel, which is supposed to be giving the advice that the government says they are taking. And so much so that even Norman Swan doesn't know what the official medical advice is from the medical advisory panel. So the problem is not with the scientists. The problem is actually with the government, which is actively stifling the news. They don't want the official advice to get out. They want to sell the advice that they want to follow. So when they say they're following the medical advice, what they're really doing is they're listening to the medical advice, maybe, and then they're doing whatever they bloody well want. And they're saying that's what the medical advice told us to do. And indeed, any good politician would do the same. Let's be honest. Let's recognize that that's what politics does. But I'm not going to be bashing politics too much. I'm more interested in the problem as a whole. I'll take a step back later in my presentation and not just talk about the pandemic. I'll talk about climate change as another issue where, as Ray said, there's this absence of certainty. The scientists don't actually know all the answers. They know an awful lot, and I'll show you some of the things they know. And so it is with this pandemic as well. The scientists know an awful lot. If you go to the British, what's it called? It's HSE, it's the Health Services in England website. They've got reports by the dozen telling you exactly what's going on. It's all in the scientific literature. There's no mystery about what's happening. It's not being communicated very effectively to the public. And that's A, because the public doesn't care. They're not paying much attention. They're much more interested, as Joffre said, they're interested watching TV, seeing what goes on in Victoria Park. The riot is much more interesting than the science of what the pandemic is about. So the public's perspective is not necessarily focused on the science. But also the government doesn't want anyone to know about the science either, because they have their own political agenda. So that's by way of introduction. But yes, I think what you said in your comments is more or less exactly what I'm going to say. So let me now say it. Okay, let me now say that the relationship between science and politics is indeed a very difficult one. On one side, science mostly ignores politics, except when it comes to begging for funding, I suppose. When scientists want money, they become politicians and salesmen themselves. They push as hard as they can to convince politicians that the country will become instantly uncompetitive without their ongoing services and discoveries. And they try and convince industry that their ongoing profitability depends critically on their embracing the latest and best scientific advances, and therefore they should all invest in scientific research. At other times when they don't want money, scientists are not interested in politics, apart from fighting among themselves. There's plenty of infighting. But what they do is they settle for arguing among themselves and pursuing Nobel Prizes. So they really are after fame and success, and their motivation is not necessarily political. It's more personal. It's the science or the university who wants to get ahead and become the best university or the best scientist. Excuse me. In between science and the public are the technologists. Now, this wasn't mentioned in Joffre's headline for this talk, but I think they play a critical role. Scientists are not technologists. There's a big difference. Science goes out and tries to find out how the world works. Technology tries to work out how to use the science that scientists have discovered to make gadgets for people to buy. So they're in the business of manufacturing and applying the science that the scientists discover. So I draw a fairly sharp distinction between scientists and technologists. Technologists, of course, are trying as hard as they can to spread the rather myopic short-term view that we'll all be better off with an ever-increasing amount of technological wizardry. They're out to make money, and they'll do literally anything to get it. Remember, for example, the Volkswagen diesel motor emissions scandal. Volkswagen acted deliberately. They knew what they were doing, and they were prepared to sacrifice the planet's atmosphere if it meant they could make a few more dollars by selling more diesel cars. So in short, technology is a godsend, but too much of technology actually delivers us into hell. On the other side, Joffre said to me he thinks politicians are like horses, in the sense that science can lead them to water but can't make them drink, unless the scientists themselves become politicians and maybe hold a gun to their heads. Joffre's right, I agree with him, except I'd go a little further. I think politicians are more like donkeys. They're stubborn as mules, and they're hardly more intelligent. The poor old scientists, they can't even lead the politicians to water. I don't think they can even do that. Politicians are not at all interested in science. Their focus, their attention is elsewhere, like, for example, getting re-elected. So politics is set to ignore science completely, unless, of course, it happens to serve its political interests. That is, until it needs some fancy new military capability, or it needs some new technological innovations for export and profit, or it has to fix some or other disaster resulting from its own misdeeds, negligence, or ignorance. At other times, scientists can advise all they like, and to the extent that they can get away with it, politicians roundly ignore everything they say. In other words, politicians pay attention only when there's something in it for them, or it becomes embarrassing for them not to do so. Here are some examples, not from the pandemic. Consider the rollout of the NBN. What was implemented was very different from the original design recommended by the CSIRO. Now, they were scientists, they were engineers, and they put down a plan that said this will work. The government decision was to ignore the science and go with a cheaper option, which will end up costing triple by the time it's upgraded to the original CSIRO specification, which they now realize they have to do. Or consider the last gasp from the Murray-Darling Basin system, the mass fish kills between December 2018 and April 2019. Up to 3 million fish died, only because the water went anoxic. There's no oxygen in the water, became stagnant. It probably could have been avoided. In fact, it likely could have been avoided if politicians listened to the environmental scientists rather than to the economists and cotton farmers. More recently, and back to the topic, the Australian government's vaccine rollout policy is the exact opposite of the scientific advice, or it was until last week. When we discovered that the AstraZeneca vaccine had an unfortunate side effect called thrombosis with thrombocytopenia syndrome, otherwise known as TTS, and it was in maybe 2 to 5 cases per million, The scientific advice from ATAGI, the Australia's Technical Advisory Group on Immunisation, was that the Pfizer vaccine should be preferred for people under 50, as the risk of this syndrome was higher in young people. Until the recent arrival of 1 million doses of Pfizer vaccine from Poland, the Australian government's vaccine rollout policy was exactly the reverse. The Pfizer vaccine was offered only to older citizens, and the AstraZeneca vaccine was the only one offered to the younger people. This decision was entirely political and exactly contrary to scientific advice. So we can see that the government just doesn't listen because it doesn't care. I can give you a reference to the Sydney Morning Herald article that says this. And anyway, so more generally, why would politicians listen to scientists anyway? The most important determinant of what the government has to do is not to maximize the health of the citizenry. That's only part of the story. The government has, first of all, to maximize the welfare of the society, which is why there's so much trouble. There's absolutely no consensus about what constitutes welfare. Welfare has many components. Health is one, but then there's the economy, there's mental health, there's the different needs of the young and the elderly, there's business and there's private individuals, there's employers and employees and so on. And they all have different needs and different requirements, and they all think welfare is something different. They all want something else. Optimizing or maximizing the outcome for everyone is by definition an impossible task. And the government knows that. So they figure rather than pleasing some people, not others, they might as well just go out and optimize for themselves. They can't please everybody, so why not put themselves first? And likewise, now let me tell you a bit about the climate science. Australia's environment and climate change policy is an embarrassment globally, but it's also very far from the scientific advice. We know the science, okay? There's no doubt about this. The IPCC has just put out a 4,000-page scientific report. It's the WG1, the Working Group 1 of AR6, their 6th annual report. And the numbers are in. We know the facts, and I'll show you some of them. I've got some graphs to show you of what it is that we actually know. The world emits, at the moment, 37 billion tons of carbon dioxide per annum into the atmosphere. This is up from 22 billion tons in 1990. Okay, so it's an increase from 22 to 37. It's almost double. And atmospheric carbon dioxide is now at 420 parts per million, up from 354 parts per million in 1990. And atmospheric carbon dioxide is rising at between 2 and 3 parts per million every year. At this rate, we will reach a doubling, which is a doubling from pre-industrial levels of 280 parts per million to now 560 parts per million, and we'll do it by the year 2070, or maybe sooner. And that will produce a global increase in temperature of between 2.5 and 3.2 degrees centigrade. The error bar is slightly higher than that. It's somewhere between 1.5 and 4.5, but the best estimate is that it'll be between 2.5 and 3.5 degrees. This is well above the predicted safe limit of 1.5 degrees. And in fact, it's well above the catastrophic limit of 2 degrees. And well, by the time the climate reaches a new equilibrium, maybe in 200 or 300 years' time, the temperature rise will have risen considerably higher, maybe as high as 4 or 5 or 6 degrees. By then, the Greenland ice sheet will have melted, the East and West Antarctic ice sheets will have melted, and we'll all be paddling around in about 20 meters of sea level rise. It's happened before, about 3 million years ago. We have plenty of records of sea levels 20 meters higher than they are today. And now it's happening again. The only difference, and this is a very big difference, is at this time, there are between 8 and 10 billion people who aren't going to like it. Last time it happened, there was nobody here to bother. Anyway, so the scientific advice is clear, right? Leave fossil fuels in the ground and start pulling the carbon dioxide out of the atmosphere and putting it back where it came from. We might also plant some trees, that would help, and we might promote swamps and wetlands. the science is in. It was plant litter and wetlands that between 2 and 3 billion years ago, when the Earth was only about less than half its age today, it pulled CO2 out of the atmosphere and laid it down as coal and oil deposits. And it was that that made the planets habitable. Before that time, carbon dioxide was actually 25% of the atmosphere. It wasn't 400 parts per million, it was 250,000 parts per million. So just try and get your head around that. And to help you get your head around that, let me show you a slide, which I have to do this way. Okay, can you see that?
Yep.
Good. Okay, now, this is a somewhat distorted graph because it goes from 0 to 100. It's basically the content of the atmosphere by percent. If you go back 4.5 billion years to the early Earth, you can see that about the top in the sort of reddish color, about 30 or 40% of the atmosphere was actually ammonia and methane, and the rest was hydrogen and helium. The atmosphere was nothing like it is today. Then, as the temperature on the Earth cooled, and there was a massive infall of meteors and so on, we grew a large amount of water vapor. So the atmosphere was about 70% steam, okay? And then what happened was plants started to grow. Or no, then we had volcanism and that built up the carbon dioxide. And then what happened somewhere around maybe 3.5 billion years ago, when carbon dioxide was at its peak around 30-something%, what happened was plants started to grow. Now plants take carbon dioxide out of the atmosphere and they make cellulose out of it and build their bodies, build trees and grasses and other plants. They also, when they die, they fall over, they rot, and then they get covered by water or covered by dirt, and they eventually, over millions of years, turn into coal and oil. So the carbon dioxide, as you can see, fell away between 3 and 2 billion years and has continued to fall all the way to the present day on this scale. We're now down to only 400 parts per million. We were down at 280, but it was falling down to that level. Now we need carbon dioxide, and in fact plants manufacture it. We need it because the plants need it to grow. We need some carbon dioxide in the atmosphere. At around 280 parts per million, it's in equilibrium with the amount that plants need. At the same time, of course, plants pumped out oxygen. So you can see the green here, oxygen went up to a higher than 25%. Now it's hovering around 20%. And the period, that little dip in the middle there where it fell away down to about 15%, was the result of some violent volcanic activity. So you can see all the bulk of it here is nitrogen. Today, 80% of the atmosphere is nitrogen, and that's inert. That's good. We need that because you can't breathe pure oxygen. So you can see that the atmosphere is a very dynamic thing and it's constantly changing. Okay, so so likewise with temperature. This is the temperature on the Earth for the past 60 million years. Now, where the vertical lines are, the scale changes. All right, so here we're going up in tens of millions of years on the left, then we're going in millions of years, then we're going hundreds of thousands of years, tens of thousands of years, and then this is today. But the temperature scale is the same, and the temperature of 0 here is taken to be the temperature in the year 1900 or 1980 perhaps. They use different standards for 0. So this is the temperature variation. Now you can see that 40 million years ago, the temperature on the Earth was something like 10 or 15 degrees warmer than it is today. Not because the sun was doing anything different. The sun, in fact, is warmer today than it has ever been. This is all the function of the atmosphere and the relationship of what goes on in the biosphere. Temperatures fell away they went down to about 6 or 8 degrees below today's level about 30, 40,000 years ago. That was the depth of the last ice age. Now, since then, it's warmed up. And in the last 10,000 years, which is the period here with that yellow line, the temperature has been pretty much what it is now. So that's why humans thrived. We thrived because the temperature was just right for humans like us to evolve and thrive. Had the temperature been 8 degrees colder, we would not be here today. Had the temperature been 15 degrees warmer, humans would not be here today. We weren't here then, and we could not have been here then. But now look what's happening in the future. These are the various projections in sort of pink and purple and whatever other colors we have here. These are the various projections on what might happen depending on how we handle carbon dioxide in the atmosphere. Okay, and you can see that temperatures may go up as high as 10 or 15 degrees again in the next 200 years. Now that will surely wipe out humans. There's very good basic reasons for that. We can talk about them if you're interested. I won't go into detail now. But you can see that what's coming is nothing like what we have had for the past 10, 15,000 years, where we have enjoyed halcyon conditions. They were balmy and perfect for us to survive. Now, this is how the temperature rise has been going up. You can see that, you can see the labels. The orangey color here is land temperature. The land temperature goes up more than the water and more than the global average, which is halfway between. The blue line at the bottom is the rise in sea temperature, and the top is the rise in land temperature, and the black is the average. You can see that since 1880, the temperature has gone up on land by over 1.5 degrees, and indeed the IPCC announced that Australia's land temperature has gone up by 1.5 degrees in the last little while, since about 1960. Oops, sorry. Now, why is it happening? Well, this is global energy consumption. This is how much energy we humans use, okay? You can see here from the different colors. On the bottom is traditional biomass. That's the natives of Africa and Tibet and so on burning camel dung and that sort of thing. So they're burning natural biomass. Coal is this second area here. You can see there's a lot of that. Oil is the largest contributor. Gas is the next largest contributor. And then the other bits at the top are really tiny. It's a bit of nuclear, a bit of wind, a bit of solar, and that's about it. So almost all the energy that we are consuming comes from coal, oil, and gas. And that is as true today as it was 50 years ago, despite our best efforts to address climate change. So that's where it comes from. You can see here, oil, coal, and gas are the ones that produce most of the electricity, most of the energy, and the others are very small contributors. If you want some numbers, this comes from BP, the British Petroleum. They know what's going on, and they're happy to publish this data. This data is all publicly available. And you can see the numbers going up. You can see how coal, for example, we burnt 12,603 exajoules worth of coal in 1950. Now we're up to 43 or almost 44,000. So we've over tripled our coal consumption in 70 years. And the other numbers are not dissimilar. Oil has gone up by a factor of 10, all right? Gas has gone up by a factor of 20 because we weren't using very much gas then, and we are now. So you can see that our global energy consumption is rising rapidly. In fact, so is the global population. We're now at 7.9 billion. When I was born, the population of the planet was 2 billion. I was born back here. It was about 2.5 billion perhaps. So the population has tripled in my lifetime. Now, what does that mean? That's got some interesting implications. Well, the amount of energy that we use per person has in fact not gone up very much, with the exception of China and Australia, surprisingly. You look here, since 1980, Europe has actually dropped in their per capita energy consumption. They're using less energy now per person than they were using 40 years ago. Likewise with North America. North America used more energy in 1970 per person than they are using today. The whole world has seen a very small increase. That's this line down here around the 20,000 kilowatt range. And that's about the average that people use around the world. It's gone up largely because China's had a big jump and Australia has climbed steadily and is jumping up even higher. We are now among the highest consumers, apart from North America, we are among the highest energy consumers in the world on a per capita basis. Now, the fact that it's a per capita basis is exactly what makes the difference, because the number of capita is going up. As the population rises, if everyone uses the same amount of energy, then you have twice as many people using the same energy each. Then altogether, they're going to be using twice as much energy. The result is this, okay? This is the ecological footprint. We have a biocapacity per person, which is how many people we can support per hectare on the planet. Notice that that line down here is falling down to 1.6. Okay, it's falling because the population is rising. So the amount of space available per person is falling. The amount we need is 2.8. So that means that we are now 1.2 gigahectares below carrying capacity of the planet. In fact, if you look at it another way, I think my next slide shows this. No, it doesn't. It shows something else. I'll show you that in a minute. This is Cape Grim in Tasmania. It's here, right in the northwestern tip of Tasmania. It's a research station. All they do is smell the air. They collect atmospheric data. They've been doing it since 1975, and their data has been correlated with the Mauna Kea place in top of a volcano in Hawaii. Now, this is where the science is being done, and this is the kind of science that you get from it, all right? They're measuring 80 different atmospheric pollutants down there in Cape Grim. You can see carbon dioxide has been rising steadily. Since 1975, it's gone from 330 to 400 plus. Methyl chloroform is something like CFCs. These are the pollutants that were causing the problem with the ozone layer. And you can see we stopped pumping those into the atmosphere, and the ozone layer is now slowly recovering. You can see that in the data. Ozone itself is wobbling up and down. It's seasonal. It's lower in summer, higher in winter. Radon is a radioactive material. It just wobbles up and down seasonally. Cyanide particles the same. And aerosols, well, we had a peak in the 1990s because we had the Mount St. Helens eruption and a few other volcanic disasters, but generally that's okay too. So the big one that you can see, we fixed up the CFCs, so we fixed up the hole in the ozone layer. Notice the ozone hasn't increased all that much, but the one that you can see really stands out is carbon dioxide is climbing steadily. Methane's also climbing. It wasn't on this particular chart. This is Mauna Loa in Hawaii. This is on top of a volcano. This is the other research station. They're doing exactly the same thing. They're smelling the air, they're pulling out the atmosphere, and they're measuring to see what's in the atmosphere. They're not making up this data. They've been there for 40 years, and they measure the information every day. This is the kind of data they get, okay? This is a year of carbon dioxide measured daily. Notice it goes up and down, up and down. It goes up and down once a year because there are more trees in the northern hemisphere than the southern hemisphere. So that means that in July, August, and September, as the trees grow in the northern hemisphere, the amount of carbon dioxide in the atmosphere comes down. In winter, when the trees lose all their leaves, the carbon dioxide goes back up. The atmosphere, or the whole planet, breathes just like you and I do. It's an organic, breathing planet. Now, the unfortunate thing, of course, is that it's not just the plants doing it, it's us doing it too. So here you can see that it goes up and down every year, but it goes up higher every year and goes down by less every year than the previous year. And that is the way carbon dioxide is currently rising. All right, so this is from Mauna Loa on top of Hawaii. Every day they measure the carbon dioxide in the atmosphere, and that's the trend that they are seeing. They're not making this up. They're actually seeing this. Atmospheric carbon dioxide, we have records of what this carbon dioxide was for 800,000 years through ice cores in Antarctica, but here it is in the last 40,000 years. You can see at the end of the last ice age, about 15 to 18,000 years ago, suddenly it rose. It rose because the place warmed up and because plants started to grow and things started happening on the surface. Basically, before, the Earth was covered very much more in ice and snow. And then it stabilized around this level, around 250, 280. And if you look carefully, you see the line goes vertical after about 1900 on this scale. Now, that was 17,000 years ago where the last ice age was. That is what's happening now. And it's us doing it, pumping carbon dioxide into the atmosphere from coal and oil and gas. They're putting the carbon into the air that the plants took out of the air 3 billion years ago. This is what the graph looks like over 800,000 years. This is carbon dioxide in the atmosphere. Now, okay, it wobbles up and down. It goes up and down with the ice ages. You can see the peaks and troughs. You can see this sawtooth pattern. But look what is happening now. And let me show you even further. Look what will happen if we don't do anything about it. This is what carbon dioxide is going to do if we keep pumping carbon dioxide into the air. Now, this is unseen, and we haven't seen this for over 3 million years. And 3 million years ago, the place was nowhere near as habitable as it is now. We are not going to enjoy the effects of this. And it really is as severe as that. This is no exaggeration. This graph is to scale. This is how far carbon dioxide levels will go up if we leave it alone. Now, notice that if we draw a graph between world population and atmospheric carbon dioxide, the graph is almost one on top of the other. The amount of carbon dioxide we're pumping through the atmosphere is exactly proportional to the population. What that means is it's not volcanoes, it's not other things, it's us. We are doing this. And that's why that trend line is as accurate as it is. It tracks population and carbon dioxide level just goes up because we all use the same amount of power as we always did per day. And the more people there are, the more carbon dioxide we emit. And it exactly correlates with us. If it was volcanoes or if it was something else, then you wouldn't see this level of correlation. So there's no question, the data is in. We know the science, it's us, okay? Now, this is where it's going. You can see this is exact numbers. You can check out the data from historical reports. On the 17th of February in 2020, I took a reading. It was 413.85 parts per million. It was here, okay? That's exactly where we were. In 5th of April, 2021, it was there. So we are tracking above the average. We're using slightly more per capita than we used to, and the population is going up a little faster. So in actual fact, carbon dioxide is rising faster than that trend line. In fact, this is what's happening. You can see the population is rising. That's the triangles here. You can see the fossil fuel emissions are going up. They're tracking population almost exactly. And the green dotted line is atmospheric carbon dioxide. And that's what we need to do if we want to keep the climate down below 1.5 degrees temperature rise. We want to stop it. That's what's required. Now, instead of that, look what we're doing. That's where we're up to. Okay? Emissions are now off the chart. They're up the top here. Population has grown, and the amount of carbon dioxide in the atmosphere has grown as well. We have achieved nothing of the reduction that we need, this rapid decline in fossil fuel emissions. We have achieved nothing. In fact, we've made the situation worse for ourselves in the last 20 years. So I'm not optimistic about us achieving that outcome, I have to say. What about ocean levels, sea levels? Well, sea levels have risen this is millimeters, so we're talking about 8 or 9 centimeters in between 1990 and 2020, say, or 2019. Okay, it's good. And you can see it's been a steady rise. It wobbles around a bit, but that's overall the temperature. Now it's going up for 2 reasons. One of them is that water, when you heat it, expands. So if you increase the temperature of the ocean expands and the sea level rises. That accounts for about 70% of sea level rise. The other 30% is melting ice and glaciers and Antarctic ice sheets and things. All right, that's enough of that. But you can see that you can see that the science is in. We know what the science is and we know what's going on. So contrary to all of this information, the Victorian government at the moment is violating the environmental laws that they themselves passed in Parliament, and they're logging old growth forest. The government is sanctioning the logging of old growth forest as fast as it can to fulfill outstanding timber export contracts. So it's not like they're concerned. Their concern is to fulfill their contracts and get the money for their timber. It's not about saving the planet. And you know very well, in central Queensland, the Adani Carmichael coal mine in the Galilee Basin was approved by the Queensland government in direct contravention of scientific advice. And the coal is not even for our own use. We don't need it. It's for export, for money. The government is actively, deliberately destroying the planet for money. The New South Wales government approved $600 million for a new gas-fired power station in Kurri Kurri in the Hunter Valley just recently. Again, contrary to scientific advice. Now you might ask, why wasn't the same 600 million invested in hydrogen or renewable energy power with pumped hydro or sodium sulfur battery storage or something? The answer is simple. For the government, 600 jobs today is more important than the environment tomorrow. Governments around the world today continue to pay lip service to the Paris Accord, the IPCC forecasts, and everything the scientists say. And they continue to overpromise and underdeliver on their climate policies. Australia is better at doing this than just about any other country in the world. They will surely listen to the scientists one day, but only after they've destroyed the environment. At a recent Climate and Peace webinar, I tuned in on Zoom on August 10, Cheryl Durant, a fellow of the Institute for Integrated Economic Research and a former director of preparedness with the Department of Defense, and Professor Lachlan Blackhall, a professor at the ANU, suggested that it would take a crisis to get the government to change its policies. The question was put to them, what do you think it would take to get the government to change its policies? And both of them, unprompted by anyone, said it will take a crisis. Nothing less than that will get the government to change its mind. Now, perhaps most of all then, most worrying of all is global overpopulation. The population has trebled in my lifetime, and it'll be 4 times by 2050. We'll be at 10 billion. The population of the planet is rising by about 80 to 85 million every single year. That's net births over deaths. The scientific advice is now that there are approximately 3 times more people on the planet than is long-term sustainable. And hence that we should actively reduce the fertility rate. We should stop increasing the population. That's the scientific advice. It's not rocket science. Politics, of course, will never let that happen. Inverting the population pyramid is economically expensive. For example, China, with 8% of the world's land area and 20% of the world's population, currently 1.4 billion, has recently relaxed its 2-child policy to a 3-child policy because they notice that their population is aging and they feel that they need more young people to prop up their labor force. So they want more people to run the economy, never mind that the planet can't hold them. So what will happen, of course, is we'll just keep populating until the ecological bubble bursts. And then we'll complain that governments, or perhaps someone somewhere, but someone else, should have done something about it. As the old story goes, In India, a woman gives birth to a child once every 2 seconds. So all we have to do is to find her and ask her to stop. None of these are scientific questions, of course. You correctly identified this. These are all political problems. The science is in, and we know what we have to do. And if everybody did it, politics would be utterly redundant. There'd be nothing left for them to do. This is, of course, not about to happen anytime soon. The trouble is, of course, that politics is also largely powerless. We blame the government, we blame politicians for not acting, but what can they do? What can they do in practice? In a dictatorship, they can wield guns, they can kill people, they can wage wars, they can line their pockets, and they can destroy countries. Great, that really helps. In a democracy, they can engender institutionalized corruption, they can distort economies, they can do all the things that they're currently doing in Australia. But it seems they can't make people do what they really need or ought to do. Look at what's going on in Victoria Park right now. Look what's happening around the place. People are having parties with 60 people, infecting everybody with coronavirus. You can't make people do what they really need to do because somehow or other they can't get their head around it. If they try to make them do it, all they get for their trouble is that they get to lose the next election. If the government came out and said, right, from now on, we're putting into place all these constraints and everyone has to do all these things and there's no choice and we're locking down everybody and all the businesses will close, there'll be a riot, there'll be a revolution. In fact, that's what happens. What governments can do, what democratic governments do, is hang on to power as long as they can and wait for the revolution, wait for the crisis. It happened in France, it happened in the United States, in Russia, in Zimbabwe, South Africa, and countless other countries. One day it will happen here, as it almost did back in 1854. The role for science, therefore, is limited. Science might make enough noise to embarrass politicians into listening to them, but this is only usually to secure or beg for more funding. To that end, science will tell the politicians what they want to hear, rather than what they need to know. Politicians won't fund unfavorable news. Tell the politicians that we're all going to hell in a handbasket and we're all cooking in our own carbon dioxide, politicians won't find that attractive. Beyond that, telling politicians what to do goes beyond what science is equipped or qualified to do in the first place. In the ideal limit, science is, strictly speaking, value neutral. Its proper role is to figure out how the world works. That's all they have to do. They can figure out perhaps the consequences of actions, right? They can tell you that if you do this, this will happen. But they can't prescribe which consequences the population should prefer. They'll tell you that if you do this, that will happen. But they can't dictate to you that you shouldn't like what's going to happen. If you might like it, then by all means go and do it. Looking to science for a solution to political problems is just like looking to economics to solve political problems. It doesn't work. Both are just searching under the lamppost. So I think the problem is political and it isn't scientific. The bottom line is this: not everyone can have what they want, especially not if there's 3 times as many people on the planet than the planet can carry. There really isn't enough planet to go around. And perhaps nor should everyone get what they want. Garrison Keillor was joking when he described the fictitious Lake Wobegon as where all the women are strong, all the men are good looking, and all the children are above average. Dan Quayle picked up on that and said he wanted to fix up the American education system because half the population were below average. I think he needs to go back to school to find out what it means to be average. Anyway, in case you hadn't noticed, the world isn't like that, okay? Not all the men are good looking, not all the children are above average. There is a demographic distribution. It's probably a normal bell curve. And science tells us that it is a finite resource. The planet is a finite resource. So resolving political conflicts between different values, goals, and interests is a task for ethicists and not for scientists. And there I'll end and I'll invite your comments. Thank you very much.
Bravo.
Big hand,
That's
Tibor. Thank you. Just clarification questions first. I'll shoot the first. You've mentioned carbon dioxide. How about carbon monoxide?
Carbon monoxide is minimal. Carbon dioxide degrades fairly quickly in the atmosphere, and we're not putting very much of it into the atmosphere anyway. It's microscopic values compared to carbon dioxide.
Really? Okay, that's the first time I heard it. But any other questions? Clarifying information.
I just
about-
want-
That was a very
Oh,
very
first,
good talk.
sorry, Anthony.
One
Joe
at a time.
came first. Joe, one at a time. Joe.
Yeah. I just wanted to say that I want to thank Tibor for the talk, because that was basically what I was talking about, that the scientific issues have to be explained to people for them to come to life. In fact, without too much political intervention. So I think it's a very informative talk, and that's the sort of thing I was talking about. You need this sort of thing for people to be aware of before they can even begin to make any proper political decision. I have other things to comment, but others.
Let me respond at this point. If you go online and start searching, you will find there are thousands of lectures by scientists and by science communicators telling everybody what the science is. It's all there. What's happening is they're not coming out and ramming it down your throat, and the general public is not going looking for it. But it's all available. There are more science talks happening, especially this week with National Science Week. There are more science talks happening than I can zoom into. There's not enough hours in the day. So yes, the science is being done, and yes, it is being publicized, but typically the general public don't get to hear about when it is or where it is or how to get to it and how to do it, and they don't go looking. So there is a communication problem, but I don't think it's the fault of the scientists. I think it's the fact that people are generally not interested and not scientifically literate. And there's a few of people like you, Joe, there are a few people who are interested, but there's not enough of you to make it economically viable for people to come out and start broadcasting it to everybody. You're not going to get it on Channel 9 all night, every night.
I was just going to say, to go further, there's an element that I think is missed out in your approach. You're talking about scientists on the one hand and politicians on the other hand, but there's in the middle there are economists. And I think this is an entire area that you maybe touched on, but really you're not nearly far enough in what the things you're interested in. If you have, you don't have to talk big terms, national level. Let's say you have brand A and brand B, and you're trying to sell brand A rather than brand B. There might be something about brand B that it's fishy. You want to sell brand A. So economists and advertisers come along and they have all sorts of tricks to sell brand A rather than brand B. What you're talking about is saying, oh, brand B is bad. Don't buy brand B. You're a bad person if you buy brand B. That's not a very good economic way to get people to prefer brand A over brand B. So I'm not exactly sure what it is, but you can say if the green solution is preferable, brand A is preferable, you have to make it palatable, enticing. You have to, I'm not exactly sure, if people can go to a nice park, which is unpolluted, it's a very convincing impetus to get people to prefer brand A over brand B. I'm not exactly sure, but the advertising and the economics, they are there in between the scientist and the politician.
I'm not sure that it's actually between science and politics. I think that the whole society runs on economics. There are not necessarily economists involved. It's just that everybody is driven by the profit motive. And it doesn't matter if it's an individual at the local corner shop or if it's the government. Everybody in business, everybody anywhere is going to try and maximize their return for cost benefit or something. Now,
yes,
the problem also with cost benefit analyses like that is that in most cases, the people who derive the benefit are not the ones who pay the cost. You talked about having a really nice park people would go to, and that would get them to prefer maybe brand A or climate change or whatever. But the trouble is, it doesn't come for free. You've got to sacrifice other things to make that park possible, like you've got to stop burning fossil fuels or something. And the discomfort or the inconvenience of doing that is far greater than the benefit you get out of going to the park. So there are sometimes when you are trying to sell brand A, it is more expensive than brand B. It's just that ultimately you don't have any choice but to buy brand A because brand B is going off the market. So sometimes things are going to get worse and you don't always have an economically attractive choice. Sometimes the choices are much bigger than economics. Now, science doesn't get involved in that game. Science is going to tell you this is how the planet's going to change. This is how the coronavirus is going to spread. This is how this and that is going to happen. Now, what you do about it is your problem. You're the one, not you personally, but you, the public, you, the government, you, the country, have to decide which approach you want to take and what outcomes you are prepared to tolerate and what you are prepared to pay for. So how you go about changing things is not something for the scientists to tell you. The scientists are just going to tell you that if you don't do it, this will happen. And if you do it, that'll happen. And now the choice is yours. Now the choice is back to the parliament, back to politics, back to government, and back to the general public. Politics is not just governments. Let's not get that wrong. Politics is actually everything that everybody does in community. So the population is politics just as much as the government is politics. So we cannot excuse ourselves as individuals and say, oh no, it's the politicians. We are also politicians because we are members of the polity. We are members of the population. We are citizens of the country, and we are as politically responsible as our governments are. And I think that there's far too much blame shoving between people and their governments. They all say the government should do something. Well, no, the people have to do it, and then the government will follow. So I think that the economics is actually secondary to the politics, despite the fact that I agree with you that everybody is driven by economics.
Okay. Thank you, Tibor. Anthony, you've raised your hand next. So
I'm just going to make the point that unless there's a massive change in consciousness, we are headed to extinction, really. That's where the ultimate destination is. Our species will end.
Comforting thought, isn't it?
It's a comforting thought, yeah. But you're right, our behaviour and our paradigm is all based on economics. I wonder if there's a way where we can change the economics to lead the consciousness in a different direction.
Try.
And the other thing is it has...
Can I just butt in there? I like the idea.
Hey, Elmar, one at a time, please.
Okay.
Sorry.
Yeah.
What we should really be doing is we all should be going down to Victoria Park and partying without masks. You know, if CO2 is exactly correlated to the population, addressing the population would go a long way to addressing the threat to our species.
Okay, thanks, Anthony. Tibor?
We could probably try approaching the Pope and telling them they should just stop advocating against contraception. There's a few things we can do. But yes, you're right. Basically, if we keep populating and we keep doing what we're doing, then we will go, well, maybe we won't go extinct, but the population will be decimated. The prediction is that maybe in 1,000 years from today, and yes, it's 1,000 years, it's not going to happen tomorrow, it's not even going to happen this century, but it'll start happening in about 200 years' time, and in 1,000 years' time, the population of the planet will not be 10 billion, it may be as low as 1 billion. You might remember David Suzuki, the Canadian scientist, environmentalist. His prediction is the population of the planet will fall to less than 100 million. So 99% of the population will get wiped out. There'll be survivors. It won't kill everybody, but they won't be living the kind of lifestyle we're living, and they won't live a technological lifestyle, and they won't be living in a world that we can see around us today. And that's coming. There's now, I think it seems like there's now no escaping it. Now, of course, the people in this climate conference I zoomed in on, they said it will take a crisis to get people to change their consciousness. There's no other way. People don't change their minds and don't wake up to themselves and don't start doing anything until it becomes really important and really urgent to do it. Okay, we're all going around recycling our plastic bags or something. Well, that's doing about a fraction of 1% of what it takes to actually make a difference. And the government is very keen to get us to recycle our plastic bags, because what that does is it makes us feel good about ourselves. It makes us feel like we're actually contributing. We're doing something. Where the real answer is, of course, we're doing sixpence worth of nothing. We're nowhere near doing enough what we need to do to save the planet. But coming back to the immediate pandemic, I mean, you really have to wonder what planet people live on if they're out there roaming around the city spreading the virus as fast as they can, while the rest of the country is trying to say that, sorry guys, this will kill you. This is actually bad for you. What does it take? There's something wrong with human nature. Now, in fact, no, let me correct that. There's nothing wrong with human nature. This is what human nature is, and we have to learn to live with it. Human nature has evolved over the last 100,000 years, and there is only one selection criterion for evolution. And that is that you have to be just clever enough to raise reproductively successful children to their reproductive age. If you can manage to do that, you will remain represented in the next generation and evolution continues. If you're not good enough to even do that, well, then you're going to die out. Then you're going to miss out. So I haven't reproduced, so I've just got the Darwin Award. I just failed the test. But what it means is that every one of you are here today because without fail, every one of your ancestors was successful in reproduction. That's the only thing that matters as far as evolution is concerned. So we are, as human beings, just clever enough to raise children to reproductive age. We're no smarter than that. If there's anybody around who's more intelligent than that, well, that's just a bonus. Anyone who's less intelligent, well, that's bad luck. But on average, that's as clever as we have to be. And humankind is, on average, no more intelligent than is required for the ability to raise reproductively successful children to reproductive age. So basically, we're stupid. We're only marginally smarter than the average monkey, and we delude ourselves. We have this massive amount of hubris that says, we are so clever we can do anything. Well, we're not doing it, and I don't believe that humankind is clever enough to do it, and we are going to wear the consequences the same way as every other species over the last billions of years that has suffered mass extinctions has suffered mass extinctions. And we are going to go down in exactly the same way for exactly the same reason. And I'm not upset about that. That is nature. That's the way the world works. And we are not immune. We are not exempt from the laws of nature. And until we learn that, we're going to just watch ourselves go down the tubes. So unfortunately, Anthony, I don't have good news for you. I don't think there's any basis for optimism. We are going to destroy ourselves because it's what animals do. It's what people do. It's what every animal does. They dirty their own nest, and we're doing it to the planet.
Thank you, Anthony. Now, Hilmar.
That's all answered now. I just wanted to say, we keep all the recycling and looking after ourselves, hopefully not wasting too much. Waste is a big percentage of all our consumption rate. And then we produce new children, doubling them up. What's all the saving worthwhile? It makes no sense if we keep preserving and keeping the environment clean if I have double consumption next day.
That's right. Yeah, exactly. So you've got to reduce the population and reduce consumption. You've got to basically cut back on everything. Now, this raises an interesting philosophical question, which I'm happy to put to you because I don't know the answer. This is not a scientific question. This is a deeply philosophical question. And it's one which I don't see anyone providing a good answer. We are in a position now where we can play God. And I mean this in the following way. I can decide that I'm not going to do anything about climate change. I'm going to let the population go up. I'm going to do everything it takes. And then in 500 years' time, we all die out. But never mind, in between now and then, there have been 100 billion people who have had a really good life. And then suddenly it was the end. There is an alternative. We can all decide that we will maybe suffer a bit more, we'll give up on things, we'll stop using electricity, we'll stop driving motor cars, we'll go back to living like the average Bolivian peasant or something. And this way, we will extend the time for which humans can occupy the planet. We'll stop reproducing. There'll be very many fewer people. If we all stop reproducing, in 100 years' time, there'll be nobody left because everyone will die of old age. So you can reduce the population drastically fairly quickly. Let's suppose we do that. And then we can continue living on the planet, not for 500 years, but maybe for 5,000 years before a comet comes and strikes us and wipes us out. And then what happens is over those 5,000 years, 100 billion people will have a reasonably successful life. So what we've changed is not the number of people who will live on the planet altogether. We've changed when they're going to live. They can all live now for the next 500 years. That's 100 billion people over 500 years, and then it'll be the end. Or you can have 100 billion people stretched out living over 1,000 years. Well, there'll be 100 billion people living then. Now, what's the difference? We're really only deciding not whether there will be more people living on the planet, but when they will live. They can either live now and bring about the end sooner, or they can live later and delay the end until later. But maybe the total number of people will be the same. So what is the difference? What is the philosophical answer? How do you judge whether it is better to have people living the high life now and dying sooner, going extinct sooner, or living longer, maybe less quality of life, but the same number of people just get to live over a longer period of time? Really, all we're doing is extending the time for which humans can survive on the surface of the planet. That's all we are achieving, nothing else. Now, what's the answer to that? How do we talk about that? I don't know, and I don't know anyone who does. So it's an open question. I invite you to tell me how you would approach answering that question.
For those who haven't spoken, okay, John.
Yeah.
Okay.
Yeah. Thank you very much for an excellent presentation of data, Tibor. It was most impressive. The way it adds to the community's armory of information that needs to be understood. However, I do think that currently the hiatus that I referred to initially with the performance of politicians, there is an opportunity with the issue of a federal ICAC being modified and established by the public. If the public could be brought to understand they need to own their own future, not put it in the hands of people like we have governing this country at the moment, where their performance is openly described as distrustful, and as Ross Gittin said the other day, they are incompetent. And then we've got the rule of law where they are not accountable. If we can get a federal ICAC where due process addressing science and the wealth of resources in science, we can make an improvement. So I'm suggesting that there is an opportunity if people don't campaign for the huge task of presenting what politicians are not doing, but campaigning to expose them to the rule of law, where there are injurious effects being created by them by not complying with the public interest.
Okay, so how do we get the public to do that? Because it's not happening. What's wrong with us?
I think we've all got to, we've got to own our future.
Yes.
And we've got to talk to one another with the material that you've presented. We've got to be quite skillful, as not everybody can do this. Not everybody has the time to even listen. But we can create a growth with a dynamic message.
Yes, we can. Okay. And I can't do it on my own. So what I do is I do my bit of education. Now it's up to everybody else. I've got to pick up what they learn from me, and they've got to present it to people. But they've got to do it not through activism, because all that does is get people's backs up. You really don't want to just upset people or make them cranky because you're annoying them. You want to educate them, and you want to coax them. You want to get them to realize that it is in their interest to do something. You don't want to make it sound like it's in my interest that you should do something. I want you to vote for federal ICAP because I want one. That's not the way to go about it. It's not the way to achieve anything. Really, what you have to do is raise consciousness. You've got to talk to people and get them to realize that they themselves, it is in their interest to go and talk to other people and to make things happen. But that's a difficult process. It's slow, and it's up to the population at large to go out there and mobilize and get active. Now, unfortunately, it often takes a crisis to do that, because most people are interested in every day. They want to know where their next meal is coming from. They want to know how they're going to pay their rent. They want to know if they've got a job tomorrow. They're interested in small stuff. They're not interested in a federal ICAC. They just want the government to go away and leave them alone so they can go out and find food for tomorrow. So you've got to somehow impress upon them that, yes, in addition to doing all the things they're doing, they also need to look at the bigger picture of where their life is going. Most people, I'm sorry to say, are generally either incapable or are not interested in doing that. That's the political problem. And the apathy in Australia is probably higher than anywhere else in the world, largely because we're a lucky country and we're still relatively well off. And because we are as apathetic as we are, you're absolutely right, we get the government we deserve. Now, my policy for elections is when election time comes around, I vote against every standing member. I want them all to be thrown out. I don't care who gets in, because next election I'll throw them out too. The only thing I'm going to do is I'm going to vote against everybody until I get somebody in there who's halfway sensible, and then I'll be prepared to vote for them. But I want to destabilize government until such time as government wakes up to itself. Now, if everybody did that, there would be governments would have to lift their game if they want to stay in power. So there are things that you can do even at the ballot box. But people aren't sensible enough. They vote for their party because they've always voted for the party. It doesn't matter what that party does. People are basically stupid. I'm sorry, I don't want to be unkind to anybody, but people just haven't got their head around what needs to be done, and it isn't going to happen. Now, how we make that happen is a task for every one of you and me. I don't deny it. I'm in there. I'm out there doing it as much as I can. And we each have to do everything we can to try and raise the consciousness of the people to recognize that there are things out there that need to be done. So it's a task for everyone, not just a task for you and for me.
Thanks, Tibor. Other people, Fred, or?
Yes, can I pick up on your philosophical question?
Please.
Whether we should do nothing now and let a certain number of people live a good life for a while, and then there's a sudden destruction. I think the alternative, having a sustainable planet, say with 1/3 or 1/4 of the population eventually, there's nothing to stop that keeping going. You mentioned a comet. I think that's a bit unlikely, and we may have the technology to avoid that in the future too.
Yeah,
anyway.
of course. Yeah,
So anyway, I think just by definition, if we can come to a sustainable type of living, there should be no limit to that until the sun runs out of energy or blows up.
Well, that's a long way away. That's true.
I know.
Yeah, you're right. Of course. Yeah. Now, of course, what you're saying, I suppose, is that it's better to have an uncertain future than it is to be certain that you don't have a future. I suppose that's the underlying philosophical point, because you might know for certain that you're going to go in 500 years' time, and that's the end for everybody. But you don't know. You're going to leave the door open just in case you can do better than that. Now, what does it mean to be sustainable in the long term? We do know that in 50 years' time, if we keep using it at the current rate, there'll be not a drop of oil left in the world. We know that for sure. We've got about 51, according to BP, we have about 51 years of supply left. And that's all the resources around the planet. Now we find more, but when somebody announces we found 80 billion barrels of oil, that sounds like a lot. It takes us 1 month to use it up. That's how fast we're using it. So, okay, we've extended the amount of oil we've got by a month. We're not going to extend it by another 50 years. We're not going to find double the amount of oil that we've had before. It just isn't going to happen. So we're going to run out in about 50 years. Coal will last us about another maybe 80 or 100 years. Gas will last us about 80 years. So in 100 years from now, there will be no coal, no oil, and no gas on the planet. Okay? Now that we know for sure. If we keep doing what we're doing, that's exit point. There's no more fossil fuels. It takes the planet over 100 million years to build oil reserves and gas reserves. It's not going to replenish. It's not like filling up a dam with water. It's not coming back. There is no more. So that's happening in 100 years. That means that between now and 100 years' time, we will have to find an alternative power supply. Now, solar, good. Yes, we can use solar, and there's enough sunshine to keep us alive. That's no problem. We will need something like 800 million solar panels just to supply electricity for Australia. I just sat down and worked it out. It's between 650 and 800 million solar panels are required, plus battery storage, plus everything else to run Australia and get it off fossil fuels. For the whole planet, you're going to need trillions of solar panels. Maybe we can do that. It's possible, but who knows? In any case, we are not going to live the lifestyle that we are living today. It just is not sustainable. So yes, we have to reduce the population by 2/3. Please put your hand up if you'd like to be among the 2/3 that get eliminated. It doesn't get a lot of votes. And then we have to cut back on the kind of lifestyle we lead. If we wanted everyone to lead a lifestyle which is sustainable, we might have to go back to leading a lifestyle which is approximately the life of the average peasant farmer in Chad in Africa. If you look at the energy consumption of people around the planet, the average person in Chad uses about 8,000 kilowatts of energy per day or something. And that's kind of sustainable. So we're going to have to change our lifestyle. We're not going to be living in, well, we won't be able to live in cities with electric lighting and fancy motor cars. Those days are going to be gone no matter what we do. So the question is, how many people want to live like that, knowing that we are currently living like this, and how do you do it? Well, the only way you're going to get there is because you have to. No one's going to put their hand up and voluntarily say, let's all do that, because it's just not an attractive prospect. So it is very difficult to get them to do it. And if we don't get them to do it, then unfortunately the outcome is going to be that, yes, the lights will go out in 500 years' time. So it's philosophically a very difficult question, basically because it's not as simple as saying, well, let's just cut back on the population, then we'll be okay for thousands of years. A lot of things have to change. And the longer we leave it, the bigger the changes have to be in order for us to escape the mass extinction event which we're staring down the barrel of.
Okay.
So yeah, I agree with your sentiments. I share them. I'm aware of those arguments. But unfortunately, I don't know how you go about implementing that or selling the story to anyone. It's tough. It's a wicked problem.
Thank you, Tibor. How about you, Yvonne? We haven't heard from you.
No, I'm still learning. I have to say I'll wait a bit.
Sorry, okay, Mark. Yvonne, would you like to say something?
Yeah, probably. Are you hearing me?
Yes, we can hear you loud and clear.
Good. Are you hearing me?
Yes.
I could probably give a whole speech about this, but I won't. The trouble is, the elites who run the world, who created the economic model that we live under, is flawed. They might be probably the ones that survive. And people need, like, you know, the neoliberals and the corporations who put out the propaganda to influence people. they've got the power. And yeah, human beings are a complex of different people, different ways of thinking. Yeah, in a short sentence, and many have written the books about this, like Naomi Klein, Naomi Orestes,
Yep.
David Suzuki I followed him all through the 80s. I've known about this. The oil companies have known about this. They know about it.
Hmm.
And the elite has influenced and changed the regulations, like from Reagan's time. We have no red tape, because they want what they want, and most of them, I was going to say, are psychopaths, because they don't care about the rest of the people. And like me, when I was younger, I was working 2 jobs. I didn't have a clue about anything about politics and economics. You need time, which I do now because I'm older and retired. I'm studying it. And, you know, they don't care about the environment. The economic model does not care about the environment. So that has to be changed. And if there is enough people to bring about that change, because as Tibor said, who will survive? It'll be those sociopaths. The psychopaths will survive. As I said, I could do a whole hour's speech, but I won't. I'll just say the little bit of, and thank you.
Thank you, Yvonne.
Well, you're absolutely right, Yvonne. In fact, look at the people in the room. There's now 10 of us here. We are all of the older generation. We all have time to sit back and think about these things.
Mm.
Young people don't have the time. They're busy raising children. They're busy working from day to day. They're busy going about their lives. And unfortunately, this is a problem which affects everybody's life, but it's not something that everybody can do something about as part of their everyday life. To learn about this and to get your head around this, you really have to sit back and look at the big picture. And typically, people under the age of retirement don't have the time to do that. So yes, you're absolutely right. It's a problem that we have to solve as the older generation. It falls to us. Now, maybe the problem is that young people don't like listening to older people, but somehow or other, we do have to get the older people to get together and say, right, we are in a position where we can see what's happening. We've been around long enough to see what's going on. So we are going to start making noises, and we're going to try and get people to change their ways. But I think it's our responsibility as the senior population. We are the old and wise ones, or we're supposed to be. So maybe it's our job. Maybe that's what we have to do.
Okay, thank you. One person, Peter has not spoken. Can you unmute yourself? Unless, if you're having difficulty, I'm afraid he can't.
Peter, you have to click on the microphone down the bottom left-hand corner and unmute. Oh, there you go.
There you go. Yeah, now you can speak. Peter, go.
Me, Joffre?
Yeah, we can hear you now.
Yeah, look, among such learned folk, I feel a fool. I have no idea what the solution to all of this is, but it's probably people like Tibor who can help us in a little way to have an easier passage out of this earth. No, Joffre, I'm a midget among giants.
Oh, no, you're not, Peter.
You're too modest.
Yeah, indeed. Well, we've got enough time for one more question. Who would want, okay, you're eager. John, you have.
Just a quick
Actually,
one.
Hang on, let me interrupt you, John. Before you
Yep.
do, I'm happy to have you ask a question, but whoever this Gaia person is, we haven't heard much from them, and they look like they want to say something as well.
Now, Gaia is me, Tibor.
Oh, you're Gaia. Okay. All right.
Gaia stands for the I created an icon for the association named Gaia, Mother Earth.
Oh, okay.
Mother Earth.
Okay, well, that explains why they're so noisy, but I can't see them. All right, sorry. In that case, John, please go ahead.
just a question about how corporate interests might play around with the prospect of the magnetic bottle with fusion being resolved and counter the astonishing number of new technology solar panels might be needed to solve the problem. They might prevaricate, as I say, by saying that we will have a solution, or we do have an option with the resolution of the magnetic bottle, and then they might use that as an excuse for not being concerned about what you've described.
Oh, okay. Well, first about fusion. There is a story going around that fusion will be okay, will be ready in 40 years, and it'll always be ready in 40 years. And in 40 years' time, it'll be ready in 40 years. It's slightly better than that. It's not so bad, but it's still a decade away, and no one really knows. The research is still being done. ITER is still being built in France. The tokamak is being built in Japan. People are building experimental generators, power generators and reactors. So maybe one day that will come. If we get that right, then yes, we will have a large amount of fusion power to drive the planet. And then our fossil fuel extinction will be solved. We won't go extinct from shortage of fossil fuel. By then, of course, by the time that comes along, we haven't got the time. The problem is we've run out of time, because if it is, say, another 20 years before we start building fusion reactors, and if the fusion reactors take 20 years to build, we've got another 40 years ahead of us before we have gone off fossil fuels. Now, if we pump another 40 years worth of carbon dioxide in the atmosphere, we're cooked. It's too late. So we have to change now. We can't wait until fusion power solves our problem. It'll be a solution later for those of us who are left, and it'll be a solution for those of us who maybe who survive. But maybe if we can last that long, it'll be a solution. The problem now is I don't think we'll make it. So with solar panels, that's happening too. There's people putting in solar farms of massive proportions. Hydrogen power is going to be used. They're going to generate hydrogen out of solar power. They're going to use solar power to hydrolyze water to get hydrogen, store the hydrogen as ammonia, and then distribute that as fuel. That's already being built. But again, it'll take a very long time to build enough of this stuff to actually replace the amount of fuel that we are currently demanding. So the problem is time is running out. It's not a problem that the solutions won't happen. They may well come, but there's not going to be enough time to wait for those solutions. We have to do something sooner than that. So it's a timing problem more than a technological one. The technology will improve, and no doubt the scientists will come up with something, and they're working on it very, very actively. I'm a member of a physics discussion forum. We were online a couple of times last month. You could have joined in. We're talking about nuclear fuel and about fusion fuel and hydrogen power. And I had half a dozen, I was a member of a panel with half a dozen physicists, experts from CSIRO, University of New South Wales, from University of Melbourne, and we're all discussing where the technology was up to. And it all sounds reasonably promising, but it won't get rolled out fast enough. So the problem now is one of timing.
Thank you very much.
Yeah, thank you.
I will dare to we will end by my daring to answer the question that you raised, Tibor.
Yes, please.
In the area of cutting back on being the average peasant in Chad, I grew up experiencing not having enough electricity, growing my own food, not having to go to market to have my meal for the day. And I was a very happy child,
yes,
and teenager. So I'm not afraid. I'm not alone in that kind of fear. But as to the future, it may not lie in science alone, but in the combination of science and art called science fiction. And the challenge there really lies in envisioning a future. You can either use science fiction and develop a story like Blade Runner, where you run into where the world tailspins into a natural catastrophic dystopia. But there can also be a Star Trek future. And I'm a Star Trek fan myself.
Yep.
And also in strategic plan, it's worked in strategic planning to envision a future that you want and work backwards up to today in order to get at it. And I think that will take more than science, but a combination of art, creativity, human creativity. I may disagree with you that we're barely smarter than the apes because you've done incredible things when you look at the past history of civilization. And I think we shouldn't underestimate our powers of creativity. And I myself, as an economist, as I've said before, when politics and science, when politicians and scientists have common commercial interests, and I'm not talking about economics, it's different, commercial interests, where they seek maximum profitability, maximum satisfaction, and minimal costs, then I become wary, because what economists, or what the real economist really stands for, is economic efficiency, which is different from the efficiency in physics, where you maximize use of resources. But economic efficiency means a general improvement of society and individuals and inflicting harm to none. I know it's a very ambitious perspective, but I have seen it possible. Happen when I work with the cooperatives, whether it's in the third world like the Philippines or the first world like Germany or Spain and the US. And I think that's where the hope of humanity lies.
Okay, so let me ask you, Joffre. I agree with you that that is possible. Why are we not actually seeing any of that happening? Or maybe we are seeing a little bit of it happening, but certainly not enough.
All right, that's a good question, because my answer to that would be in understanding and the studying of history. If you study history as nothing merely as history repeating itself, then you have that feeling of despair and possibly hopelessness. But when you also look at history as stories of breaking through, breaking out from old patterns and starting something new, then that's the direction we should take.
Okay. Now, I have heard it said, I wish I remembered who said it, but it did say that history doesn't repeat, it only rhymes. But the other old saying I like is that the only thing we've learned from history is that no one's ever learned anything from it.
Yes, and I also have a history professor.
I somehow resonate with that. I think that's right. And I also remember from my studies of history that, yes, there are these breakings out, but invariably they are accompanied by a great crisis, by great upheaval. It doesn't come cheap.
Yes.
You're not going to have an easy way out of this. There will be a crisis, and then we'll wake up to ourselves, and then we'll change. In that respect, I think history will repeat itself. I really don't see a nice way out of this, because people just aren't going to one day wake up and say, oh, I've been in touch with my creative side. I'm now going to go and grow my vegetables and live a different life.
I have a classmate who's a history professor, and he gives another definition as history is a nightmare we have to wake up from.
Yes.
And I agree. I've been through 2 revolutions myself.
Well, I've been through 1. That was enough. Thank you.
Well, I've been in two, and they were both a pleasant surprise that it was non-violent. I did not expect tyranny and organized crime in both different cases.
Mine was violent, unfortunately.
Yeah, unfortunately.
Not so nice.
But maybe because I've experienced a peaceful solution to the crisis, I'm an incurable romantic. All right.
Well,
I've got sure hope because of my experience.
well, more force to you. Good luck, and I sincerely hope you're right.
Thank you.
I'm not advocating for the glum outlook that I see. I'm not suggesting that's a great thing and we should all look forward to it.
Mm-hmm.
I'm rather putting it up as a view that says if we don't do anything and we don't wake up to ourselves, then that is a distinct possibility. And the probability is rising. So it's a warning rather than a voice of despair. It doesn't have to be like that, but it is looking like it more and more because we are waiting longer and longer to do anything about it. And the crisis hasn't yet happened. It's not yet crunch time. And by the time it gets to be crunch time, it's going to be difficult. That's what I fear.
Yeah. My good news is I'm sure I'm not the only hopeless romantic in the world. Thank you.
And good luck to you.
Thank you. And thank you, everyone. This afternoon, I hope we ended up on a high note. Some of you know Tibor personally, so you can continue this conversation even after this conference. Thank you very much, Tibor. You've been great.
Pleasure. I hope that everyone in the room got what they hoped to get out of this afternoon's conversation.
Yeah, I hope so.
Thank you for the invitation, Joffre.
And thank you for accepting. Thank you.
Thank you, Tibor.
Thank you.
Thanks, Tibor.
Thanks, Tibor.
Thank you.